Real estate investment practice problem using OneNote. Amortization schedule, changing the terms, keeping all the other factors constant, looking at the impact on the payment, amortization schedule, and other calculations. Get ready because it's time to raise the stakes with real estate. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon, left-hand side. We're in the Practice Problems tab down in the 4130 Amortization Schedule Term Changes tab. Also note, when using OneNote, take a look at the Immersive Reader tool. Our practice problems will also be in the text area. Same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, calculations on down below. We're going through our practice problem once again, this time keeping everything else constant but changing the term, in other words, the amount of years that the loan will be covering. This one has its own little unique kind of twists that will be involved as we go through the practice problem. We do this in Excel, so if you want to take a look at it there and work through the problem, you can, although you have to do some more formatting and whatnot as you go through the Excel worksheet. Here, we'll kind of list out the situation, and then if you want to construct it in Excel and or use the existing Excel worksheet for your own needs to make your own decisions, then you can do so. So we're going to be changing the years. We're going to be keeping the loan amount constant. We're going to be keeping the rate constant. We're focusing in on the changes to the payments. That's typically the first way that we kind of think about things, meaning we have our basic components of the payment calculation, how much we would owe each month, that consisting of the amount of the loan, the term, and then the rate. And we can change each one of them one at a time. This time, we're going to be changing the term in terms of years. So basic start line calculation, we got the 500,000 loan. Home value, we're going to assume we have the 20% down. That's 100,000 on the down payment. Loan, then 500,000 minus the 100 or the 400,000. The years where we're going to focus here, we're going to start at the basic 30 year. Then 30 times 12 would give us the number of periods that would actually be calculated. So as we change the years, then it will populate the related months down below. The rate, remember, is the yearly rate, which is going to be held constant. Now, the first thing we might do is we might say, well, what would happen if I changed the years to like 15 years or 10 years or something like that, or change it up to 40 years on the payment calculation, holding everything else equal? We can do that by simply changing this number in our data worksheet. If we have populated it correctly, that'll do similar job as you might see in a calculator, an online calculator such as this, changing simply the amount of the years here from 30 to 25 or something like that, that then having an impact changing your payments. So that's the first thing that we would think to do, and we could set that up to do quite easily. The next thing we might say is, well, what if I line up my years side by side, in this case in increments of 5 years, 5, 10, 15, 20, and so on, so that I could see the impact on the payments holding everything else equal right next to each other, which can give us a nice example rather than jumping back and forth as we change one cell reference to see what the impact will be down below. We could do that with a formula. We'll take a look at the formula. Once we have this set up, then we can do our little drop down thing in Excel, the little drop down trick to have this drop down then pulling from this series of data 5 through 40. You could check that out in the Excel worksheet. So if we were going to set this up, we could set up 5 to 40, and we could try to say what would the payment be in those relative ranges, noting, of course, that some of these ranges are going to be more likely to be a standard kind of setup when you're talking about home loans, 30 kind of being the standard, 15 being somewhat of a default, but you might have somewhere some options for the terms in this range. Okay, so the calculation then would be equals negative in order to flip the sign to make it a positive number, which you might put in front of the PV, but I like to put it up front if I can. PMT, the brackets are going to be the rate. The rate is going to be that 5%. That 5%, that's going to be a yearly rate. We need the monthly rate, so we divide it by 12. Also note that that rate is outside of our table here. Therefore, we do not want it to move down when we copy down, so we make it absolute. That's with a $sign before the B and the 7. You only need a mixed reference, $1 sign in other words, but an absolute is easier. So we do that, comma. Then we've got the number of periods. The number of periods is where we are focused here. Notice that means that we're going to be picking up the periods from this cell, not from our data set over here. We're going to pick it up from this cell. Then we'll use our data set to pick up the drop down from this range of data. So we're going to pick it up over here, which in this case would be the 5 years. This is in years, not in months. Therefore, we're taking that cell and multiplying it times 12. Also note that we do want that cell to move down. Therefore, it's not absolute. No $sign before the A and the 15. Then, comma, we got the present value. The present value is going to be the loan amount, which is not the home value, but the loan amount, the $400,000 in this case, picking up this cell. This cell's in our data set, not in our table. Therefore, it needs to be absolute. In other words, we do not want it to move down. That's why there's a $sign before the B and the 4. If we copied that cell reference down, then it would look like this. And so you can see the comparison in references, PMT rate, same thing here, B7 because it's absolute, divided by 12, referencing that 5% divided by 12, comma, number of periods. Now this one has moved down from A15 to A16 times 12, which is the 5 down to the 10, 10 times 12, and then comma, the present value, same cell, B4, $signs involved, didn't move down. That represents the loan amount of the 400. So that gives us our first amount, that side-by-side kind of comparison that can help us get that immediate look at what is actually happening. If we then use our reference tool to basically hit the drop down, we can change this number then to be calculated from a drop down, which we'll do in Excel. We can also double check in our data to the left. If I picked 30 here, for example, the payment amount comes out to $2,147.29, which should match the 30 here, 2,147. We didn't add the pennies here, so it's rounded. Once you have that information, the data on this side will then populate the amortization table. The amortization table, if set up properly, will then be adjusted and changed with changes to the data input, such as the years. And this will give us our 360 payments, helping us to break out on a month-by-month payment, the payment versus the interest. If you want to look at how to put this together in Excel or how it's constructed, look at the prior year or prior presentations. And the point is, of course, that there's going to be a difference between the interest and principal calculation that makes it a little bit more confusing than to make other decisions on. Therefore, we might add a table as we've seen in the past, and we might use our slicer tool. Our slicer tool allowing us to see this information by year. So we got year 2, we got the total payments, total interest, the loan balance, which is nice. And so we could see that breakout. But that's also limited as well because we can only see 1 year at a time. We might want to see something like these totals broken out on a year-by-year basis. And for that, we can add a pivot table. Now note, when we look at these terms, we have that added wrinkle we were talking about here. Like, for example, what if I was to change the term to 10 years? Now, if I don't change my amortization table, I still have this table that's going to be representing 360 rows, but I don't need 360. I only need 120. So in other words, if I was to not change my worksheet, use the same worksheet, and scroll down past 10 years, you could see the amortization table worked up until 10 years. But then it goes down to 0, and now I've got these negative numbers, meaning I should kind of delete the table after this point in time. However, it's not too bad, it's not a big problem to have this table extending on because you still have your check figures up top, meaning I don't really need the totals at the bottom of the table. What I really need is the breakout on a month-by-month basis as to what the interest and principal will be. I can get the total amounts calculated right here, and I can get the breakout on a year-by-year breakout with either the use of the slicer tool, the filters, or with a pivot table. So note, for example, here, I don't need the bottom of this table to figure out the totals. I could just say, well, I know that my payments are 4242.62 times, now the number of months is 120. That will give us the 509,114. And I know if I subtract that minus the 400,000, that's the amount of interest paid over the entire term, in this case 120 months or 10 years. So the fact that the bottom of the table is not really relevant to us, it doesn't really matter to us too much because we could see what we need to see, which is the breakout up top. Also note that if we were to change this to a 40-year term, you got to make sure that your table then extends on past 30 years to 40 years to pick that up. We may not have that in our Excel worksheet, although I think we do have that in a future one. So just remember, you need the table, of course, to be picking up enough data for however long you're going to extend the terms to, and the fact that the table extends beyond the date shouldn't matter because you could still see that it's calculating properly by the fact that it's going down to 0 at the end of the term, in this case 10 years, 120 months. So that's one of the little twists with the term down here. And so these total numbers down below aren't going to be useful to us, but again, we can calculate those totals up top without too much difficulty. Now then also note that we could take this information and then do our pivot table. I won't spend a lot of detail, adding the pivot table this time because we've seen it in a couple presentations, so we do it in the work problem. But if you could add the pivot table in the same fashion, that allows us to get this nice, easy breakout between years 1 through 30 and a breakout on a year-by-year sum basis of the payments, the interest, the loan reduction amount, and then the loan balance. Once again, look here that if we only have 10 years, this data is still going to go down as far as the years go that we set the table up to 30. So everything past 10 is irrelevant. But again, that's pretty much okay for us generally because it's still giving us what we need, which is the yearly sum of the interest, and we still have the yearly breakout of the loan balance. So that gives us basically what we need, and it also allows us to use this pivot table to change the data to pull any other kind of reference information that we might need much more easily than we might see elsewhere. So if I was to change this, for example, to 15 years in our data set, and we look at our table, this is our data for 15, you can see it then goes down to 15 years, down to 0 then. The rest of it is irrelevant, but that's okay. It's going to give us the information we need, hopefully. We have 30 years. We could do the same kind of thing. Of course, here's the 30-year data going down to 30, and we might use that information, adjusting the pivot table, to then put together other tables and worksheets that would look something like this. So, for example, if we kept the loan at 5% stable, $400,000 loan, or I'm not sure if that was the balance of the home or the loan, but if we kept that constant and then we changed the terms, meaning 10 years versus 15 years versus 30 years, then we can use our pivot table up here, refreshing the pivot table based on the terms, copying then the sum of the interest and the loan balance for each to get the loan balance calculation over here and the interest, and then we can do our comparisons. Now, again, you're going to get this tiered kind of fashion when you're changing the terms because this one only goes to 10 years, 15 versus the 30, but you can then get your totals down here and break it out fairly nicely without too much added work, and you can see your loan balances as they would fall out if you were to change the term and keep everything else constant fairly quickly. Remember, these tables down here are going to take a little bit more work because you're going to have to refresh the table, copy and paste them 1, 2, 3, meaning values only. They will not be adjusted automatically as you adjust other factors, but you can build them fairly quickly with the use of the pivot table. So we do work this in Excel. We have an Excel worksheet, so if you want to see how to put this together and customize it for yourself, or if you just like to use the worksheet to make decisions, you can do so.